All right, so starting chapter 4, we actually skipped 4.1 in this course. So we're going to start chapter 4 with section 2. Um, and so this section is looking at maximum and minimum values. And this is just talking about graphs. So the idea of a maximum and minimum value is probably something that you're familiar with and probably pretty intuitive at this point when we're talking about graphs. So the maximum value of a graph is just the highest point or the biggest y value that you can get from this whatever function that you're looking at. And likewise, the minimum is the smallest or the lowest point on the graph. So max and min are always talking about the y value or the value of the function. And we can talk about absolute value, our absolute maximum, absolute minimum. We can also talk about local max and local min. So I'll let you can read through over those definitions. I won't read them to you. But let's just look at this example. So we have this graph here of the function, the polynomial, and we're restricting the domain to or between -1 and 4. So you can see it has a couple of turning points. There are a couple of curves here. And so this point here is the highest point. This point is higher than this one over here. So this would be an absolute max right there. This would be the absolute minimum. And there's only going to be one absolute max, one absolute min per graph. Maybe. It is possible to not have one. We'll talk about that as we go along here, but there's not going to be more than one absolute max unless they happen to come up. I guess you could have another point over here that would come up to, like if this came up to 37, then that would be another one, but they're the same values. 37 is the maximum value, the absolute maximum value, and -27 is the absolute minimum value on this interval. Now we have up here, it talks about local max and min. Local max and min is just around that point. It is the smallest point or the biggest point. So here we have a local min. Here we have a local max. So it's different from the absolute. The absolute, there's not going to be one more than that or less than that if we're talking about the minimum. Local max and min is just around this point. Locally, it is the highest point, or locally, it is the lowest point. And then again, this would be a local max. So you can actually have an infinite number of local max and min if you're talking about some periodic function that looks like that goes on and on forever, and these points are all the same value. Then we'd have an infinite number of local max and local min. So there's really no parameters on that. But that's the idea. So the absolute is the absolute biggest or the absolute smallest. The local max is just around that point. It's going to be the biggest or the smallest. You can find that. You can just find those wherever the curve changes direction, and that will give a local max or a min. But again, like I said, this is pretty intuitive as far as what we're talking about. So nothing too abstract here. So moving along, so the extreme value theorem. If f is continuous on a closed interval, then it always attains an absolute maximum value and an absolute minimum value. So a couple of keywords here. We have continuous. We know what continuous means intuitively. Now closed, when we talk about closed interval, probably you've heard this term, but this is just talking about we're including the endpoints. So on all of these, we're on the interval from A to B. A is in the interval and B is in the interval. So we're including those endpoints. If we're not including those endpoints, then may or may not have an absolute max or min. And so you can see all three of these on this row are closed intervals. We're continuous, and we have absolute max and absolute min for each of them. And in this case, it looks like we have two absolute maxes, but they're again the same value and one absolute min. Now, in this case, this would be an open interval here, and it's not continuous. So we have a discontinuity here. And so there's actually, there is an absolute min. So that would be the absolute min, but there is no absolute max because you never actually get to that point. So that point, if it was included, would be the absolute maximum. But it's not included. And so you're gonna, the graph approaches that point, but it never actually gets there. So no matter what y value you pick, and it looks like the open circle is at 3. So no matter what number you pick below 3, you can always get another number bigger than that one that is still below 3. So in other words, if you pick 2.999, there's still another number between 2.999 and 3. So you can just add another 9 or add another 9 or add, you can keep adding numbers to that decimal and you'll never actually get to 3. So there's no absolute max. And then here, this is an open interval on both ends. So we're not including x equals 0. So we never actually get down to 1 in this case, the y value of 1. And then, of course, going this way, we go up to infinity. So there's not going to be an absolute max there. So in other words, in order to have an absolute max or to be guaranteed to have an absolute max, it has to be continuous and a closed interval. If one of those things is not true, you still could have an absolute max or a min, but not necessarily. So, all right, so let's talk about how to find these. So most of the time, we're not going to be just looking at graphs. You can do that in any algebra class. And so this is calculus, so we need to figure out some calculus to do. So if f has a local max or a min at x equals c, and if f prime of c exists, then the derivative at c will be 0. And so remember, the derivative is just the slope of the curve at a particular point. So if we have a curve and here would be a local max, and the tangent line, the slope of the tangent line is 0, which means the derivative is 0. So all that means when the derivative is 0, we have a flat part. And as long as it's going to go back in the opposite direction, then the derivative has to be 0. So if we have a max and the derivative exists, then the derivative is 0. Now, the opposite is not true. So just because the derivative is 0 does not mean we have a local max or min. For instance, x cubed looks like that. The derivative is 0, but that is not a max or a min because it doesn't change direction. So the opposite direction here is not true. If f prime equals 0, then there's a local max or min. That's not true necessarily. And so we call these, wherever these are, we call these critical numbers. So a critical number is a number c in the domain. That's key. It has to be in the domain of f, such that the derivative is 0 or it does not exist. The derivative does not exist. So let's look at a couple of examples here. Find the critical numbers of this function. So we're going to take the derivative and set it equal to 0. So a prime of t would be 3t squared minus 12t minus 36. And we're going to set that equal to 0. Let's factor out a 3. And then we can divide by 3. We'll get rid of that. And then FOIL or factor out t squared minus 4t minus 12. And so we get the critical numbers are t equals 6 and t equals -2. Okay, that's really all you're going to do. A lot of things we're going to do in chapter 4 involves taking the derivative, setting it equal to 0, and this is the first derivative. It's not the second derivative. Not doing second derivatives here. All right. Next example. Find the critical numbers. So this would be x to the 1/3, and so we can use the power rule. So we get 1/3 x, and then subtract 1 from the exponent, so -2/3. And then we can write this, put the x on the bottom here. And there's nowhere that this equals 0. So never equals 0, but x equals 0 is not in the domain of this. It's not, the derivative does not exist at 0. The reason I put the graph on here, you don't really need the graph for these. In fact, it's probably a good idea if you get used to not looking at graphs when we're doing this, because we're going to get in a couple more sections to curve sketching, to where we can look at this graph and we can or look at this function and sketch the graph. We can look at this function up here and sketch the graph. So you kind of want to get used to not necessarily needing to look at the graph, because you're going to need to be able to sketch it on your own. But if we look at this one, at x equals 0, we have a vertical tangent line. And when it's a vertical tangent line, that means that the derivative does not exist. Okay, but still a critical number. And we have these two up here for this one. All right, and then the last thing that we're going to look at, the closed interval method to find the absolute max and min on a continuous function on a closed interval. So we find all the critical numbers in the open interval between a and b, which is doing the same thing we did in the last two examples. And then find the values of f at the endpoints, and then we can get the max and the min from that. So let's take the derivative of this. 3x squared minus 6x, we're going to set it equal to 0. So we can factor out a 3x, and we're left with x minus 2. So we get x equals 0, x equals 2. All right. Now, one thing you got to be careful of, if we had come up with, so the derivative or the domain here is -1/2 to 4. If one of the x's here was, say, x equals 5, we could ignore that, because we don't need to worry about an x that's outside of this interval. Okay, so if x had equaled 5 or x equaled -1, we would not have to worry about that. But 0 and 2 are both in this interval, so we're going to consider those. Now, we really just need to find f, plug in the endpoints of the interval, and plug in these two critical values. And we're plugging it into the original function. So let's see what we get. So -1/2 to the third minus 3 times -1/2 squared plus 1, and we get 1/8. And then f of 0 is just going to be 1. F of 2 is going to be -3. And then f of 4, which is the end of the domain, we get 17. All right. So now at this point, all you need to do, so we're looking for the absolute max and the absolute min. It has to be one of these. This is a continuous function, and it's a closed interval. And so the theorem we saw earlier says there has to be an absolute max and min, and it has to be one of these. So we found the critical numbers. We have the ends of the interval. And so we're just going to pick the smallest number and pick the biggest number. And that will give us our max and min. And that's all there is to it. The only tricky part, I know it's not even tricky, it's just something to remember, is, again, if you get, say, x equals 5 when you solve the derivative equal to 0, that is not in the interval, so we would not count that. So that's really the main thing you got to pay attention to. So, but if you have any questions, feel free to email me, and we'll take care of those.